Good afternoon, everyone. Today's topic is game power consumption optimization. As game content, gameplay logic, and visual quality continue to intensify, power consumption optimization has become an increasingly critical challenge. Over the past year, we have conducted extensive research and practical experiments on power consumption and summarized a relatively quantifiable analysis methodology. Let's start with the first part, tool introduction. A traditional approach is to use GOT Online, which provides an overview of the overall power consumption trend. In addition, our free tool Gears also provides power curves, allowing us to observe overall power trends during testing as well as the final average power consumption. However, the limitation of these tools is that they cannot explain the root cause of power increases. For example, whether the increase is caused by GPU pressure, CPU load, or other system components. Therefore, we have been searching for a tool that supports quantitative power analysis, allowing us to clearly identify which module is responsible for abnormal power consumption. During our research, we first tried Treppen Profiler. Although its name suggests power-related analysis, we found in practice that its data dimensions are very limited. It mainly shows frequency changes for a small number of CPU cores, which provides limited value for detailed analysis, so we eventually abandoned this approach. Next, we tried BatteryStats via ADB command line. BatteryStats can collect power consumption data by process UID, including screen, CPU, audio, video, and Wi-Fi related metrics. By organizing and visualizing the data, we can roughly observe power consumption trends across different modules. For example, a steeper slope indicates higher power consumption for that module. However, BatteryStats is still relatively abstract. It cannot precisely identify which behaviors cause CPU or GPU power increases, and it also lacks some key module data. Later, we discovered the Power Rails feature in Android Studio. Power Rails breaks down power consumption across CPU, big, middle, and little cores, as well as GPU and display, providing very detailed data. However, Power Rails also has several limitations. First, it only works on Google Pixel devices. Second, the application must be debuggable. Third, profiling duration cannot be too long, otherwise the data volume becomes difficult to analyze. Eventually, we recommend using Perfetto for power data collection. Using the Perfetto web interface, we can enable battery and power rails tracing and support long-duration tests, such as 1 hour. Although memory size is limited, setting it to 64 megabytes is generally sufficient. On the main interface, click Record New Trace, select Web USB to connect the device, then click Connect New Device and choose the connected phone. Once the green status text appears, the connection is successful. Click Start Tracing, run the test for a period of time, and then click Stop. In the analysis results, we can sort modules by average power in descending order. In some test cases, GPU is the primary source of power consumption, indicating that GPU optimization should be prioritized. In other cases, CPU big cores contribute the most power consumption, which usually indicates optimization opportunities in logic, animation, UI, physics, or loading workflows. With this approach, we can clearly identify the primary sources of power pressure. Another important advantage of Perfetto is that the target application does not need to be debuggable. Even production games downloaded from app stores can be analyzed directly. Of course, there is still a device limitation. Power tracing currently requires Google Pixel devices.